Ever find yourself wondering, like, how do these apps get so crazy fast? We're talking like lightning fast, boom, instant responses. You know, the kind that you don't even like realize you are even using an app. Well, today
It's pretty amazing.
we're going
Yeah.
deep into the tech that powers those experiences. Like, we are going to be talking about serverless computing and its pretty interesting relationship with databases.
Yeah.
Now you've sent over some really cool research on a topic, and it's a bit of a mouthful, I'm not going to lie.
Sure.
Serverless runtime, database co-design with asynchronous I/O.
Yeah, that is a mouthful.
And that might sound a little intimidating, but don't worry.
Yeah.
That's why we're here. We're going to break it all down, make it fun.
Make sense of it. Absolutely.
So no worries.
Yeah. Yeah, it's a fascinating area, really.
Yeah.
Most people, I think they get the idea of apps running on servers, right?
Yeah.
Those big, powerful machines.
Yeah, humming away.
Yeah, in data centers somewhere.
Mm-hmm.
But serverless computing, this is kind of flipping the script. We're changing things up a bit.
It's like, so instead of having a dedicated server like chugging along 24/7, even when no one's using the app,
Right, exactly.
it's more like on demand.
Precisely. Think of it like this. Imagine, would you rather have a taxi idling outside your house all day long, just waiting for you, burning fuel even when you don't need it?
Way.
Or would you rather just order a ride-sharing service when you're actually ready to go?
Exactly. Yeah.
Serverless is like that ride-sharing service for computing. Developers can run their code only when it's needed, which makes applications super scalable, super cost-efficient. So you're not wasting resources. You're only paying for what you actually use.
Okay. I see the appeal there for sure. No waste. Just pay as you go. But there's got to be a catch, right? Like, it can't be that easy. What's the trade-off here?
You're absolutely right. There are always challenges. One of the biggest ones we bump into is, how do these serverless apps actually talk to databases? Because, databases, those are the massive stores of information that apps rely on, right? And traditional databases, they were built for these constant, always-on connections, not for these quick bursts of activity that are like the hallmark of a serverless world.
So it's like you've got this amazing team of chefs raring to go, ready to cook anything at a moment's notice, which is awesome.
Right.
But then they end up waiting forever for someone to actually bring the ingredients from the pantry.
Exactly. It slows the whole thing down. And that's precisely where this whole concept of serverless runtime database co-design with asynchronous I/O comes in. Basically, we're talking about how to make these systems work together more efficiently.
So how do we make it work? How does this asynchronous I/O thing actually work in practice? It sounds like we're trying to teach the chefs to prep other dishes or something while they're waiting for, that key ingredient.
That's actually a perfect analogy. Basically, asynchronous I/O lets the app keep doing other things while it's waiting on the database. Instead of hitting pause on everything, the app can use that waiting time productively. Imagine
Yeah.
your banking app, right? It's fetching your transaction history, which takes a minute, but in that time, it can still be updating your account balance maybe, or letting you schedule a bill payment or something.
That's so smart.
Right.
So we can finally say goodbye to those annoying loading screens, and the app just keeps chugging along in the background.
Exactly.
Is this where multi-threading comes in?
You got it. You're right on track there. Multi-threading, if we want to simplify it, it's basically like having multiple cooks in the kitchen. Each one can handle a different part of the order all at the same time.
Makes sense.
Asynchronous I/O uses techniques like that to make sure that even if one part of the app is stuck waiting, other parts can still run smoothly.
This is making a lot more sense now. So this research on serverless runtime database co-design with asynchronous I/O is a big deal because it's solving that exact problem, optimizing how these two systems work hand in hand, right?
Exactly. It's about making sure the information flows smoothly between the serverless functions and those databases. The research actually digs into some really specific strategies for cutting down what we call latency. Think of it as the delay before a transfer of data starts after you've asked for it.
Okay.
And obviously, it's all about boosting the overall efficiency.
Yeah.
Long-term benefits. Huge.
This isn't some abstract tech thing either. It impacts everyone who uses apps, which is everyone these days. Faster, more responsive apps, sign me up, right?
Absolutely. This has the potential to completely change how we experience technology. Imagine streaming a movie with no buffering, even during peak hours when everyone's online, or online banking transactions that are processed in milliseconds.
I like the sound of that future.
Right, it's a game changer.
So as serverless becomes more and more the norm, what are the bigger implications? Where do we go from here?
That's the big question, isn't it? This whole shift towards serverless computing and advancements like asynchronous I/O have the potential to really fundamentally change how apps are designed and built in the future. Don't be surprised if we see an explosion of even more responsive, crazy data-intensive applications. And these will be apps that just blend seamlessly into our lives. You won't even notice them.
It's pretty wild to think about. Well, that just about wraps up our deep dive for today, but here's something to chew on. As this technology keeps evolving, are we even going to notice the difference? Or will this kind of seamless, instant response just become the new normal that we expect? Something tells me this is just the start of a wild ride.
I think you're right.